something we need to think about is coupling or matching the rate at which fresh air comes into our lungs with the blood flow through the lungs. So ventilation is that first one. Remember that the bronchioles, which are right around here, those are little bronchi. They're smaller than bronchi. That hyaline cartilage is kind of petered out, and now we have smooth muscle surrounding those. That smooth muscle can constrict or dilate. So we can have bronchoconstriction to restrict and reduce the size of that airway, the lumen, or bronchodilation, which makes the lumen larger and is going to regulate fresh air entering the alveoli ultimately. So larger lumen, increased ventilation. We want to match up this ventilation with the blood that's passing through the alveoli. This is called perfusion. Perfusion is talking about local blood flow to tissues. In this case, perfusion is local flow, blood flow, right, to the alveoli. So these two things we want to match up so that we have optimal gas exchange rates. So if you remember, in the skeletal muscle, we talked about local regulation of perfusion. So in the skeletal muscle, we had, in the case of low oxygen or high carbon dioxide, we had what happened to the arterioles. We had vasodilation to increase flow to those tissues that need more blood flow through them. The opposite is going to be true in our lungs, which actually makes sense because the opposite things happening. We're exchanging the opposite gases. So in our pulmonary, actually I'll say in the alveoli, it's going to be high O2 that causes vasodilation. That kind of makes sense, right? Like if we have high oxygen, we want to have more blood flow to get that oxygen to the body. Likewise, low CO2 is actually, and this is where there's another caveat, is going to dilate our bronchioles. I'm sorry, I saw that just in time. This is high. High CO2 is going to dilate the bronchioles to be able to exchange that CO2 out. So it's two opposite mechanisms for the two gases. Okay, let's actually look at this. So here's two scenarios. In this case here, we've got ventilation. I'm going to say perfusion is greater than ventilation. So that could be due to low ventilation, bronchoconstriction. It could be due to high PCO2 and low PO2, which often go hand in hand. This could be the cause of having perfusion be greater than ventilation. When this happens, this is here. Here's our so what's going to happen in this case is we're going to have what we have right here. High CO2 is going to dilate our bronchioles, bronchodilation. We also may have some constriction, vasoconstriction. The opposite of what's happening here, right? So this is going to cause ventilation to go up and or perfusion to go down. On this side here, we've got ventilation happening at a higher rate than perfusion. This could be due to high ventilation, so high dilation, bronchodilation. It could be also due to low PCO2 and high O2, PO2. What's going to happen? This high PO2 is going to cause vasodilation. Where is that? That's right here. That's going to cause increased blood flow through here. So actually, I have pictures show up here. Let me add in my pictures. There's my pictures. Yeah. So here you can see vasodilation right here. That is going to cause increased perfusion. In this picture here, we had vasoconstriction, is what's shown here. Can't really see the bronchioles getting larger, but that dilation does occur. Either way, here we have a mismatch. Here we have matched up.